As you see, we're going to be working with a wooden board, a protractor, which is really just for show, as we'll see, and a book. And in that situation, we know that the book on the board won't fall at first, but if we raise it, at some point it will slide down the board. You know at all times gravity is acting straight down. So let's look at the friction that has been preventing this. We see that there is static friction at first, and this is a graph of static friction and the other friction, kinetic friction, as opposed to the applied force. As we increase the friction, the force on the object, the friction increases to a point. At a point at which the static friction is overcome, the amount of friction decreases and the object moves, and we're in the area of kinetic friction. Let's look at it again, see what's going on. Gravity is pointing down. As we lift it, gravity is acting down, but it can't make it fall straight down, so it makes it fall along, that's the applied force, along the board. At some point, as we lift it, the force of static friction is overcome and the book slides down. So this is a very interesting situation. We should look at the forces that are active in it, and we can see that we have the force of gravity is straight down, we see in that situation. That force is broken up into two pieces. One which is perpendicular to the board, the force that's smushing the book into the board, and also force that acts down along the board, and that's what brings the book down the ramp. In addition to those forces, we have the static friction which acts up the board and resists the motion. And finally, we have, because the book is pushing into the board pushes back by Newton's third law, and we have a normal force, a reaction force, which acts up on the book. We can identify very clearly the equation. The force is down the ramp, which is a component of gravity, is the mass times the acceleration due to gravity times the sine of the angle that the ramp makes with the horizontal. The force that's pushing and smushing the book into the board, that's creating the frictional force, is the mass times the acceleration due to gravity, which is 9.8 generally, times the cosine of that angle. Okay. Further, we can identify now the frictional force, which is the coefficient of friction, that mu. This mu is the coefficient of friction between the board and the book. The normal force is the force smushing the two surfaces together. It's that component of gravity. We see that the frictional force is mu times the mass times g times that cosine of theta. So that's the breakdown in terms of our angle theta and the mass of the book.